Welcome to this presentation of Augmented Testing by Synteda. I'm going to talk about what is Augmented Testing and also present our tool for Augmented Testing, HiveMind. My name is Emil Allegroth and I'm one of the people behind this product and this concept at Synteda. And I'm going to, as I said, present this technique and tool for you. So what we're talking about here primarily with augmented testing is automation, where we know today when it comes to software testing that it's in many cases still some type of manual work, manual operations that are performed by humans, but that automation is being introduced more and more in this context. The automation that is being performed is primarily through automated scripts, low-level, high-level test cases of some sort, primarily maybe through unit testing, integration testing with low-level frameworks, but automation has also started to become a thing on higher levels of system abstraction and testing on high level of system abstraction, which includes then testing of the graphical user interface or testing through the graphical user interface. The challenge with high-level automation is that it's often quite cumbersome to create these test cases, especially developing them and maintaining the test cases. And the question that has arisen then is if there is any better ways of doing it. Is there a way of combining perhaps manual and automated work to get the benefits of both, where benefits from manual testing include things like having the human as an oracle that can observe defects and problems that you cannot observe necessarily with strictly guided automated tests, because the human has this capability of seeing things that are strange behaviors of the system under test or strange behaviors in the environment that are not necessarily observable through automated tests, that are told to observe very special things in very specific ways. So the idea here that we're talking about is automation through the use of human knowledge and understanding in order to transfer that into more automated tests. And the benefits that we are seeking are the same ones as for automated testing, where we want to improve test quality, we want to improve efficiency and effectiveness, efficiency through reducing lead times, overhead costs and costs in general, and for effectiveness, the amount of defects that we can find, the coverage that we can achieve, etc. And the question then becomes, what is augmented testing? Augmented testing is a new concept that we define as software testing performed through an augmented GUI from which user inputs are recorded, managed, and augmented through machine learning and artificial intelligence. And here on the right side of the slide that I'm showing you is an overarching view or architecture for how this works, where the key component is this augmented GUI that lies on top of the actual system's GUI. The idea here is that rather than to write test cases or create test cases in a separate environment from where the tests are being executed, we instead modify the system under test with additional test behaviors. And this is achieved through this augmented GUI that can be seen as a head-up display or in the same lines as augmented reality, where we do modifications to the graphical user interface of the application of the test with additional test inputs. And what we see here then is a model of maybe, let's say, a web application where we have a main screen, we have some other components, and then in the augmented UI we have this layered view, this glass pane, let's say, with some blue, orange and green squares that overlay the components on the screen. I will show you more of this in the demonstration later. The idea is that instead of interacting directly with the system on the test UI, the user instead interacts with the augmented UI, giving that input both for interactions like traversing the application through clicks, or drag and drop or whatever it might be, as well as data such as typing in usernames, keywords, input data. And all of this is then recorded through the Augmented UI into the Augmented Testing tools, different components such as a test model, some ML, machine learning AI components that make use of the input data, and other test features that may include everything from how to do the automated playback of test cases to how orchestrating how the machine learning AI is supposed to work, etc. So what we're doing here is that we're clearly separating the augmentation and the test functionality from the system under test. So therefore, the system under test, the interface between the augmented testing and the system that is being tested is this bridge between the augmented UI and the actual GUI. This implies that we can test the backend through this approach, but we do so through the graphical user interface. And I'll get back to more of this in detail later. So I've been talking about UI testing and also UI-based testing, and it's important here that we have a distinction between the two, where UI testing is about how we test the visual appearance and the look and feel of the application on the test. So assume here that we have Synteda's web page. The GUI test of this web page or web application, if we want to view it as an application, is that the graphical components are positioned in the right place, have the right size, right colors, but we don't really care if they work or not. Mostly we focus on that everything looks correct. UI-based testing, on the other hand, is more about verifying that the behavior of our application when we interact with it, that works as intended. So for instance, if we were to click on the news button there on Synteda's webpage, then we expect to perform a state transition into the web page that shows us the news from Synteda. So what we're doing there is that we're triggering actions, and we expect some behavior or change in state in the application we're testing. And this is then what we would refer to as UI-based testing, testing the behavior of the system rather than its visual appearance. To do augmented testing, you need some tool support. And we at Synteda are proud of our tool that we've developed called HiveMind, which is a tool for augmented testing. It has a lot of different functionality, and it then conforms to this definition of augmented testing, where we have an augmented GUI which allows the tool to visualize test inputs or test cases, test inputs, suggestions and other things on top of the actual GUI of the system that is being tested. The approach conforms to something that we call scriptless testing, where test cases are recorded into a model, and you as a user do not have to write any scripts for this or interact with any scripts or technical code. Everything can be managed, orchestrated, and both recorded and replayed through the graphical user interface of the application. HiveMind then supports the scriptless testing, where you orchestrate everything that has to do with tests, from developing to maintaining to running the tests through the augmented UI and the tool. This augmented UI then also serves to record test cases. So you record them through the augmented UI, and then they're saved in this in the model or in a model that contains both the test functionality as well as the test inputs and everything that might be needed. The augmented UI then supports both manual and automated replay of all the test cases that you have created. So you're able to both interact with the GUI, replaying test cases that are that have been manually recorded previously, and just simply clicking through them to do regression testing. Alternatively, you can automatically replay them. You also have then machine learning in the back end of the application, which continuously analyzes the input data and the test sequences in the model in order to identify patterns and to find what the expected behavior is of the application from user inputs. This means that the tool is able to reverse engineer much of the behavior of the application we're testing that can then be stored as an automated oracle for more exploratory automated testing. Meaning that when you do random testing, which is commonly used in practice for finding crash defects or defects where you can no longer interact with the application, instead this provides an oracle where it's much easier to find the faults on finer levels of granularity. So instead of just identifying sequences that lead to the entire application crashing, you can find things like this input resulted in an unexpected output, similar to the type of faults and failures that a human would identify. You also have the ability in the tool to export things, so both tests can be exported. So if you want to use the tool simply as a recorder, you have the capability of doing so. But you can also get reports of different kind from the automated execution, from the manual execution, so you can keep track of what type of failures you have in your application and where they're at, which states that are affected, what actions lead to these faulty behaviors, etc. Similar to most test tools, also it has continuous integration, meaning that there are simple ways of triggering the test cases as recorded in the tool from an external environment, such as a continuous integration environment with Jenkins or a Team Foundation server or whatever it might be. This is done today with the REST API in a very simple manner. On the right side here, then there is a high-level model of the architecture of the tool, where we have the system UI, and that is the system of the test that we aim to obviously verify that it conforms to its requirements. That is connected to the tool through the Augmented UI. Inside the core of the application, we then have the model handler, which deals with all the test data and sending data, recording data into the model. We have the test model itself, which is basically a weighted graph of sorts that stores all the test information, actions, as well as how often certain paths are being traversed, and additional information that can be used by the machine learning AI algorithms in order to provide better or more valid suggestions to the user. And I'll get back to the whole suggestion concept in a little bit. Then we have the plugin orchestrator, which is also part of the core, which deals with all the different functions of the tool that can be imported through open source plugins. These plugins, they define everything that is in the tool, from the look and feel of the Augmented UI to how replay is performed, to the test driver, which governs which type of application that we can test. In the standard version of HiveMind, the test driver is Selenium, meaning that the tool is primarily focused on testing web applications. However, we also have in the workings test drivers for Android, and we're working on test drivers also for Windows and other operating systems. In addition, we have plugins there that deal with the model data, what type of data that is being stored, and being open source, this is designed in a way that the users with a little bit more technical knowledge can rewrite these data model, or the data model on what data is being stored, to configure the tool for your testing purposes. In addition to all of this, we also have tool configurations such as what types of components you can interact with and what you should not be able to interact with, also how you should be able to interact with them, or what you should be able to interact with. I was talking about suggestions. So if we take a look at an example of what is a suggestion, what's the purpose of it. Assume that in our web application we have some percentage field where we keep inputting percentages, and if we input, let's say, 55% and we submit this, the tool will recognize this as a valid input. It will store it in the data model. And basically what will happen is that the data model that is stored, the scriptless behavior, the model will be augmented or expanded with more data. So in this case, it would store the data value 55 there as an action. What the tool will later do then is that the machine learning algorithms that lie in the back end, they will continuously look at the inputs that we're providing, and it might then recognize that we keep inputting values between 1 and 100 because those are valid percentages in this case, and thereby recognize that you always keep inputting numbers between these boundary values. What happens if you input a value higher or lower than these boundaries, 1 to 100? Why this is of importance or of interest is that it's been observed that testers that do exploratory testing, they get something of tunnel vision, meaning that even though they aim to explore the application in new states, new ways of testing the application to seek out and find new faults, they keep inputting the same numbers and the same inputs that they were used to before. The reason for this is because there is an built-in reward function in going to places in the application where there are previously known faults, because there is a higher chance, probability of finding faults there. And humans being humans being wanting this reward will subconsciously be drawn to those areas of the application where the faults are. Then being suggested a value outside of this norm of values can then push the user, the human, to try new things, to provide more coverage of the application. So what will happen in the tool is that input value will then show up with this purple or pink boundary stating that here is a suggested value of 101, and it's then up to the user to either select this value or skip it. But the idea here is then that you would choose this value, and if this results in failure of some sort, that the system responds in a strange way, the tool will then learn from this, and through reinforcement learning provided by the human, and then be told basically that good job, I like that suggestion, please provide more similar suggestions of this type. So in this case that could be values such as -1 and 102 to see if there is a common or similar behavior of the system for such values. This is valuable both for functional testing, that the system's output corresponds to the requirements, as well as security testing and that type of testing where there could be unknown vulnerabilities in the application for certain values that the user, developer, or other stakeholders may not have considered when developing the application. The tool here provides you with such suggestions to eliminate such threats. So what are the benefits then and possible limitations with this tool then? Well, the benefits are that you get more efficient test creation. Recording test cases have, through also academic studies, shown, and with this tool, shown to speed up the test development process with up to as much as a factor of 10, meaning that you can create 10 test cases in the same time as it would cost to create one scripted test case. You also have the a benefit here of automated execution, which you would expect from an automated test, or automated testing tool, but you also have the ability here to do both regression testing as well as exploratory testing. And exploratory testing comes from the tool's ability to provide suggestions, randomize data, but then still basing this random testing upon the recorded scenarios provided by the human user, which then increases the validity of the randomly generated test cases. Another benefit is the ease of use. Since everything is administrated and managed through the Augmented UI, every stakeholder associated with the tested product or the tested system can contribute to the tests. You can even have developers recording tests for you. You can have requirements engineers. You can even have the end users, which was not or is not necessarily possible with other techniques like scripted test techniques that require quite a high degree of technical knowledge. The tool is also highly expandable due to this open source plugin architecture, where you can write your own plugins, or you can modify the existing plugins to fit better with your context. So if you're not happy with how the automated scripts are being replayed, you can simply rewrite the replay plugin to get a different behavior. The tool is also integratable. You can run it in a CI environment. You can export the test cases if you want to run them as part of your existing web testing test suites in this case, or in the future Android or other test suites. So this provides you with a lot of flexibility. The current limitations with the tool is that it only works for web testing at the moment due to the tool working primarily with this web driver. However, we are actively working with and expect to soon have a driver also for Android. So that will expand the capabilities of the tool. Of course, we are going to provide the tool with the same other features such as the machine learning and all of those other beneficial components. And another limitation could be the setup and configuration of the tool, which is highly contextual and depends on how you have developed your web application. For standard web applications that comply with standard components used for widgets on the web, such as buttons, drop-down menus, etc., the tool should work out of the box. However, if you have custom components written with JavaScript or other web-based technologies, the tool facilitates some easy ways of configuring the tool to enable actions also on these components. And with that said, the idea here is now to run a small demonstration of the tool. So I'm just going to switch over here now to HiveMind so we can take a look at what the tool looks like and how it executes. So let me just start it here for you. So here we have HiveMind's the HiveMind tool, and this is the start screen that you come to. And what I'll show you first is just on a simple application how to quickly create a test case. So you click on start here, you select the application that you want to run. So in this case I want to use this web page called Traveler. I select it, and here I have the possibility of doing some changes if I want to, but I'm gonna save these default settings. And then I'm going to start the web application. So what's happening now is basically that HiveMind is launching the web application that I want to test inside inside HiveMind, which is then working as a web browser, and this allows me now to interact with the application. And as you can see here, I've already recorded a test case here, or two test cases, which are shown here with blue squares. This means that this is previously inputted data. So if I hover here over this blue square here, we see that I previously clicked on hiking, but this time I want to go caving. So I click on caving, and here we directly get one of these suggestions that previously we have clicked on France and going to France for hiking, but I don't want to do that. I want to go to Canada for caving. So I select that, and once more we will get a suggestion here to click on search, because that is what has happened previously. So I click on that, and it will take me to this new page where I get further suggestions of what to do. However, I'm going to ignore all of these suggestions, and I'm going to go here and say that I want to plan a vacation. And that is the next action that I want to take. So click. And for some reason now the web page doesn't proceed. Okay, so what we'll do then instead is that we'll click on buy here. That should take us to a new page. And what we can do here now then is that, okay, here are the options we have for caving, swimming, etc. And I want to check these for in future test cases automatically, that these values here are correctly shown on the screen. So what I simply did was to click on them, and as you can see here, I can hover over everything here and add those as checks. I can even go in here and change what is supposed to be asserted. So you see here that says gullwing, text gullwing. So what I can do here is that I can write gullwing, text gullwing, and I can write something else here. So let's say that we want to check that it says 198 instead. And if I add that, we will notice here that there is something wrong here. The expression here is evaluated to false, so our assertion has failed. The tool expects 198 to be 1998 to be the output, but output that it's observing is 1999. We can then here choose to either click on this assertion and to rectify it, to update the data to 1999, or we can type here that this is a bug. So we can write something like faulty value, and then we click on it, and you notice now that the border here turns red, meaning that we have reported a defect. So with that, we claim then that we have found a defect, and what I'll do now is that I'll tell the tool that I want to go home to the home state. And you'll notice now in this graph here in the beginning that visualizes our test cases that we then have a defect here. What I now can do is either to do additional test cases, or I can follow the existing test cases that I already did. So what we did here was to do hiking. So I'll tell the tool that I want to go hiking, and then I'll select another country here, and you see there in the graph that the tool keeps expanding the test cases that we have available. But I won't continue with that. I'll go home again, and then I'll tell the tool that I want to go caving instead, like we did in the previous case. And you see here in the graph that we're now traversing the same test cases previously, and here once more I have the ability to change country, but I will continue with the test case that we previously recorded, and I can simply do this by clicking on the blue squares. Alternatively, what I can do is to tell the tool that I want to automatically execute this. So instead of manually going through the test cases, I'll simply click on the auto button, and the tool is now running these actions automatically. And unfortunately now we can't see so here now it's clicking on buy, and now it's reached this page where there was a fault, but it will ignore the fault for now and then continue back to the home screen and continue to execute the other test cases. You will notice now during the automated execution then that down to the left the bars there with green and blue are automatically filling up, and that's measures of the coverage we have of the test cases we recorded. And the One of the bars shows the coverage of the test scenarios that we have, meaning the edges and vertices of the graph, and the second one shows the coverage of unique web pages or pages of the application we're testing that the tool has been able to identify. So this provides us two different types of coverage. You may have noticed also during the execution here that it stopped in one position and said that it automatically repaired href, and this is a functionality of the way the tool does auto repair of components. So if a component is changed during execution of the test case, meaning that you have done changes, for instance, to the application, added new widgets or changed any existing widgets in any way, the tool, rather than to have to rewrite the test cases, which is the common way of doing things in script-based tests, the tool here automatically updates the changes based on the information that it has available. And this information includes the properties of the component that it's searching for, as well as neighboring information. So the tool now here continues to execute, and it will do so also because I have added here in the plugins that I want the tool to do random exploration. If I were to go back to manual mode here and I go to plugins and disable this random exploration, it will not continue to execute the graph forever, but rather aim to fill complete the coverage of the test cases. So in this case here, it will go to this final node that it had not visited, and we can now see that we have 100% coverage of our test cases that we have previously recorded. So I'll go back here now to the home screen and then just show you a little bit about the plugins that are available in the tool. So first of all, we have this state graph. We can disable and enable that if we want to. We can even, if we want to, disable the GUI, if we want to remove all the if we want, for instance, an end user to test our application for us without seeing all of these augmentations on top of it, we can disable that function and still interact with the application to do things, and everything is still being recorded, but it is being recorded in the background. So if I enable again the augmented state, the test that I just added was to click on contact and then go back to the traveler, and we can see here that that has been saved for us, even though that wasn't visualized on the screen. So what we can do more here is that we can enable other plugins that are very helpful for creating test cases. So for instance, we can enable this plugin here called Widget Metadata, which you notice here now that when I hover over components, we get a lot of additional information about the test cases or the components. And this is valuable to see the XPaths, what children they have, what tags they have, and this can be used for varying purposes, to create test cases, to do assertions based on these tags, etc. You can also enable more help information if you want to. So if you want to click on things here, you can see here that this yellow text was added, and this could be valuable help for new users to see what does it mean to do a click or a check or whatever it might be. So if I scroll through things here, we can see here that we are selecting the different things. We can see here that we can search for things by clicking, we can move, and so on and so forth. And we get a little bit of more help information there. We also have things like augmenting the actual output that is shown or visualized in the Augmented UI. So we can turn the images here into grayscale, for instance. This could be very helpful for usability or user experience testing, where you would like to identify that you have high enough contrast between components in order for, let's say, colorblind users to be able to distinguish between your components. So this could then be a very helpful tool for that type of thing. So let me just enable the state graph here as well. So I also mentioned in the presentation prior that there are some limitations to the tool, that it might not work for all components just out of the box. But there's a simple way of fixing this, and that is why also it's good to have this metadata plugin available. So here we can see that this check here, that is being performed with the tag H1. You see that at the very bottom right of the metadata box. What I can do here is to go to Tools and then Widget Identifier. That will present us with this pop-up window, which has a lot of tag information in it. And this is for augmenting how the tool interacts with certain components in our application we're testing. And what I want to do here now is to go to check, and I want to disable H1 tags. So I don't want them to be checkable anymore. I don't want them to be something that we can automatically assert. And the way I do this is simply to remove that here and click apply. And when I go back to the application here, we now see that the tag, it can still check this component, but it's now checking it through the div tag. So what I can do here then is that, no, I don't want this component to be checked at all, is to remove also the div tag. And now when I hover over it, or apply, save, it's still finding this tag. Oh, okay, I changed it in the wrong place. No? Very interesting. It was supposed to disappear here. Anywho, the idea here, the demo monster is here among us. So if we add these ones again, we can now see at least that it's once more using the H1 tag here instead. So assume here that you had a component that you would not want, that the tool wasn't able to identify to do a click on, for instance, then we can add the tag here. I can show you this by here in the click option, add the H1 tag here, and when we hover over this, we then suddenly have the possibility here of clicking on it. You see that the action here is now click rather than check. So that is the way you add functionality to the tool to interact with specific components. To show you a little bit more about what you can do with the suggestions with the tool, I'm going to stop this application and start another application here. It's a simple calculator application that is does addition, subtraction, and stuff like that, and I'll show you how the tool creates an automated oracle for this application. So I'm going to start the browser. And you may notice that this is similar to our Traveler application, but it's for demo purposes. So we have this calc up here, so I'm going to go there, and this is a simple form that you would see in most modern web applications. And what this does here is that it performs an automated or performs a calculator action, addition in this case, or subtraction, but we'll use addition for for demo purposes. So let's assume that we want to do 1 plus 2, and we press calculate here, and we tell the tool that we want to check this value, that the output of 1 plus 2 equals 3. Good. Then we tell the tool that we want to go home, and we now have our recorded test case, so we can go back here to calc and just wait for it to load a little bit. And now we see here that we have saved our previous value 1, that we can automatically input by clicking here, but we can add another input. So I'll input 2 plus 3 here instead and press calculate, and the output is 5 as expected, so we tell the tool to check that the value is 5. Good. We go home, and then we go back again to calc, and we input maybe 3 plus 1 here instead, and we can then press calculate, which is suggested, and we see that the value is 4. What we now notice here is that we get a purple box around the output here, which says that check, I've found a pattern, add box 1 and text 2 and text 3, and that should provide us with value. So by inputting these three combinations, the tool has now automatically identified that the behavior of our application here is similar to a calculator, meaning that if we input values in the first and second field, those two should be added. And now, it has now produced an automatic oracle for us that identifies the behavior of the system. And this is very powerful then, so what we'll tell the tool is, yes, well done, use this oracle. So simply clicking here that it will use that as an assertion, and then we can go back home. And now with this information, we can tell the tool that we want to do random exploration, and we want to do it automatically. So the tool will now go through here and use a combination randomly of the inputs that we have previously provided, as well as additional inputs that it finds. So for here, it will continue to add values and going through the tree and basically explore this functionality for us. So now you notice that inputted 0, which is a new value that we hadn't added before. You can also see that in the state graph that it's suddenly expanded with a new branch. And here it's adding another value and checking that that works. And it will continue to do this until it either finds a fault or until we tell it to stop doing it. You can also notice here that we have a little bit of latency on the web page, that the calculator form is loading in different intervals, and but the tool has a very advanced way of waiting for components, so therefore it's it always ensures that the state of the application is ready for inputs before it takes the next action. Hence, no more need for manual weights and stuff like that. And now suddenly you notice that the assertion here turned yellow, and this is because it found a strange behavior here. -3 plus 2, we expect that to be 2, not 4. And this is something that then doesn't match with our pattern, so we can tell the tool here to that this is a fault. So so what we'll do here is that we'll add a check here, and then we'll report an issue that this is a fault. -1 plus 3 should equal 2. So we report that here, and we now have an automatically identified fault. Of course, I expected this to happen because we've seeded this fault, but it's for demonstration purposes. But this showcases the strength of having this automated oracle that I automatically identified that for a given input here, -1, we got this faulty behavior here in the output. And this is something that a normal random testing tool would not be able to identify because it would not have this calculated model in the backend to compare to. So this is one of the very interesting and cool features of the tool, I would say. So you can go back here now, and you see here that we now have our fault recorded here, and we can act on that in different ways. Good. Now I'm gonna check if there are any no questions from the chat so far. This is the core of the tool. You also have the possibilities, as I mentioned, to export things here. So we have under reports. You have the possibility here of exporting a session report that would be the results from this current test run, regardless if it was driven through manual testing or through automated testing or even exploratory testing. You can generate Java unit tests, and what will happen then is that the tool will take the graph that we have here and export it as Java code with the unit test framework. One aspect which is added to this is that the exported test cases will use this the same type of widget localization that HiveMind uses. And this widget localization is using multiple properties of the components at the same time in order to identify the components more robustly. And this allows the tool to do the automatic verification and also automatic repair of components. And the repair mechanism is built into the framework that is being used, or the library that is being used for the multi-location, meaning that your exported test cases will also automatically repair themselves even if you're not running them from inside HiveMind. You can also export issue reports. You can generate the test cases as Java source code if you don't want to use the JUnit or Java unit test framework, and more. Other things that you can do is that you can set and accept cookies if you want to. This is valuable, for instance, if you have an application that has a login feature, for instance, so you don't have to log in every time. You can instead set the cookies such that you only have to log in once. You can also bookmark things and go to bookmarks. So for instance, if we wanted to this is combined then with the navigate function over here. So assume that we want to navigate to our newly found defect over here. We can tell the tool that we want to navigate to this is a fault -1 + 3 = 2 that I just added. And what the tool will now do is that will highlight the test cases that will lead us to that fault with this larger bold blue square. So we simply follow that in order to get to the fault. And we can see here then that we have a bold value here, and as you remember, we have many different values inputted, but if I scroll through them, you see that there is only one that has this very bold blue border, and that's -1, which we remember was the cause of our fault. Similar here, we have multiple inputs, and if we click calculate, we are now here at this destination, and you can see here reach the destination, and here we have our fault. This is very valuable if we want to navigate quickly to our faults during regression testing in order to verify if the faults are still there or if they've been removed through the changes we've made to our system. You could also, as I said, add bookmarks in a different location. So let's say that we wanted to go to calc here and we want to add a bookmark here. So what I can do here is simply then that calculator app, I'll call this bookmark calculator app, and you see also that the state graph here is augmented with this information, and now we can navigate to it and use it for other purposes. For instance, if we want to name these different test cases different things and give a higher level view here in the state graph of what's going on. So now I'll go back to home, and we can see here then that we have in our bookmarks here this new isset calculator bookmark here that we can use for various purposes if we want to. Yes, and you can see here that there is a lot of different plugins available, and as I mentioned in the presentation prior to the demonstration, all of these are open source, so they allow you then to add new functionality and modifying them. We have, for instance, down here the autopilot, which defines how the test cases are being traversed. This can then very simply be rewritten if we want to. And we have all of these other plugins that we can also look at if we want to. And that's about it. I won't demonstrate how to configure this to run with the continuous integration. Know only that this is something that is very simple to do using the REST API. And we at Synteda Somatic, we have of course offer support for helping you setting this up. If you want to set up either the application in a way that to make it run in a continuous integration fashion, or if you want just training, you are more than welcome to contact us. And you can reach us either at somatic.com or synteda.se, or you can email me directly at email@synteda.com, and we are more than welcome to answer any questions you have about the licensing model, how to get access to the tool, what other offers we have in terms of education and support. And we hope that you've enjoyed this presentation and hear from you soon. So with that, I thank you so much, and see you next time. Bye.